Hello, welcome to my channel. I'm Ameya, and today we are going to see another problem, different type of problem in ANSYS APDL. So today we are starting with thermal analysis, and this is the problem in front of you. So we have a wall, and the thickness of wall is divided into three different types. The A material, and it is having an insulating material B from the in between sandwiched, and let's see how we can solve this. So dimensions are given, properties are given. We need to start with our thermal analysis today. So I have started with the ANSYS APDL, new job name, new working directory, and we are ready to go. Okay, so first we will start with preferences. Now here the first change will happen. You will change this from structural to thermal because we need our elements and everything to be segregated in thermal background now. So this will help you out. The preference, we are going with the thermal now, and if you check the element type, you will see the change. All the elements are now thermal elements. Okay, thermal link, thermal mass, all these are thermal elements. So we are going with solid quad 55, that is a plane element. So what we will be doing is we will be solving this as a 2D problem. So we will be creating areas, we will be doing meshing on that areas, and then we will be solving it for the final answer. Okay, so let us see. So for area element we need plane 55, so we have created plane 55. There is no real constant required. We will go to material properties, material models, thermal, and we have conductivity given in our data. So we are going with isotropic conductivity Kxx, and that value is given with us. The A value is 55 into 10 raised to minus 3, and B value is 0.1 into 10 raised to minus 3. So we are having two materials here. So it is 55. Sorry, just click there. 55 e raised to minus 3. 55 e minus 3. Okay, and adding one more material, second material, that is zero point 0.1 e raised to minus 3. As this is an insulating material, it will have low value for the conductivity. Okay, let us check those values one more time. 0.1, yeah. So we will go to the ANSYS APDL, we will close the material model tab, and then we can go with the modeling part. Now in modeling, first you have to create three different areas. So we will go and create the areas. Create areas rectangle. We will be doing by two corners, and we are mentioning our first corner as 0, 0, and we are going with width and height. Now the thing here we need to understand is the width or the dimension is given 2 mm, 4 mm, 2 mm, that is the thickness of a wall, and we are assuming that to be a unit length. So height we are assuming to be a unit, so that is 1. So we will go for 2 by 1, or you can even go by 2 by 2. That is not going to change your answers. So we are assuming it to be 2 by 2. So first it will be 2 by 2. You will get one rectangle 2 mm by 2 mm. Then we are going with another rectangle, but this time we will change x because we need to access this point. So either you can click here directly, you will get 2, 0, and then you can give width to be 4 and height to be 2. That will give you the second rectangle, and third rectangle x will be 6, y will be 0, width will be 2, height will be 2, and this is how you can create three different rectangles. Now, what we need to understand here is when we go for a thermal analysis and there are different layers of the 2D area, we need to make sure those areas are connected together. Right now, these are three single entities, three different entities. Okay, so for that, you have an operation called Boolean operation. Okay, so we need to attach those so that whatever property I am giving on right hand side, it should go towards the left hand side smoothly. Okay, so for that what we need to do is we will going to operate Boolean, and we will be gluing these all areas together. Okay, so we will be going with areas, select all the areas and make sure those areas are glued together. Okay, this is the important step when you go for a thermal analysis for a 2D. So be don't forget to do this if you want a correct answer. And then we are going to the meshing and mesh tool. Now we have two materials, so we will be setting areas. Set the first area and the last area. Okay, and we are making it material number 1. Okay, that is the A material we have stored. Okay, then you can go for area sizing. We will size these two areas, and the length is, our total length is 2, so we will try to get at least 10 elements. So I am going with 0.1 as the element edge length, and then I will be meshing with quad free both. Say okay, this will be my 0.1 area. Now the remaining part I will go with this area now with second property. Same thing we will perform, sizing 0.1, and then I will be going for a mesh. Okay, so this is how you can get a uniform mesh throughout the area. Now the loading part is very easy. When you go to the thermal analysis, you go to define loads, apply. Now here you will not get the force and pressure because that is the part of thermal analysis, sorry, structural analysis. In thermal you get the thermal loads, those are temperature, heat flow, convection, all those things. So here we are going to apply a temperature on key points. If you are saying key points, you have to select a key point. If you are saying nodes, you have to select a nodes. Okay, so I'm going with lines, selecting this left side line and making it temperature and making it 0. Okay, so 0 temperature on this side. Again going for lines, and I am applying 20 degrees on the right side. So what will happen? Temperature will start distributing from the right hand side towards the left hand side. It will go from high temperature to the lower temperature. So this is the only thing which we need to do in loads. Go to solution, solve, current ls, and your solution will be done. Okay. So what kind of results we want to see? You can go general processor, plot results, contour plot. You will be going in nodal solution, DOF, nodal temperature we will see, and this is how the distribution is going to be. Okay, so because of the change in conductivity, the isolation part, the B part, is basically absorbing all of the temperature, and it is not going to change any temperature on left hand side. So this is what you get. So we will be going for plot. We will capture this image, we will store it somewhere. Yeah, so thermal, and you can easily get this as the answer. So you have list results also, you can have nodal solution, you can have DOF, thermal temperature, and you will get a temperature distribution at each node which you have already seen in previous problems too. Okay, so this is how you get the solution for the thermal analysis. Don't forget to go for the preferences of a thermal analysis, then the element type, and important step is gluing the areas together. Unless and until you glue the areas, you will not see these kind of temperature distributions in your 2D thermal problems. Okay. So this is what I want to discuss in this video. This is the conductivity problem. We will be coming with more problems on thermal analysis. So stay tuned. If you like this content, subscribe my channel, share my channel, and share a word about channel with friends. Thank you for joining.